wish you all a happy Independence Day. So let's begin with our session. So we have the next topic, chemical property, that is reactivity towards oxygen. So reactivity towards oxygen, when group 15 elements they react with oxygen, they form oxides. They form oxides. They form oxides of E2O5 type and E2O3 type. Correct? They form oxides of this type, that is trioxide and pentoxide. E stands for the element. Now, nitrogen, the first element of the group, it forms many oxides. It reacts with oxygen and it forms many oxides. But the rest of the elements of the group, they form 2 type of oxides or 3 type of oxides only. But only nitrogen is the element of that group which forms many types of oxides. Many oxide it is forming. Now what is the reason for this? So the electronic configuration for nitrogen is 1s2, 2s2, 2p3. For oxygen it is 1s2, 2s2, 2p4. Correct? Oxygen atomic number 8, nitrogen it is 7. So see the electronic configuration, the valence shell it is 2p, 2p. Correct? So 2p, 2p overlap will take place. That is p to p overlap. And a pi bond will be formed. This we have already discussed also. In nitrogen we can see p pi to p pi bond. Correct? pp, both the orbitals they will overlap, so a pi bond will be formed. Correct? So easily the bond is formed between nitrogen and oxygen. Why? Because both are 2p and 2p. Both belong to the second shell. 2 is the number, right? Both. And same shell means the energy is also same. No difference in size of the shell, no difference in the energy. So they can form bonds very easily. Now take the example of other elements of the group, that is for phosphorus. Phosphorus, the valence shell you will have 3p. I am not writing the entire electronic configuration. Okay, the valence shell we have 3p. For arsenic we have 4p. For antimony it is 5p. And for bismuth it is 6p. Correct. Now oxygen has to make bonds with this, means here it is 2p. Correct. Here it is 2p. So 2p and 3p. 2p of oxygen and 3p of phosphorus. Slight energy difference is there. Slight energy difference is there. Correct. So it can form 2 or 3 bonds and 2 or 3 oxides are only found. Now as we go down the group, you can see it is 4p, 5p, 6p. So the difference in energy between 2p and 3p, little difference. 2p and 4p, little more difference. 2p and 5p, little more difference. Correct. The difference in energies goes on increasing. Correct? 2p and 3p, slight energy difference. If I say 2p and 6p, the energy difference is very high. And because of this, as we go down the group, the oxide formation also decreases. Because of this energy difference, the oxide formation also is decreasing. And that is the reason nitrogen forms many oxides, many type of oxide. We will check that also. And nitrogen forms many oxides than other elements of the group. Hope it is clear to you. So let's write some examples of oxides here of different elements of group number 15. So we have for phosphorus, we have P4O6, we also have P4O8, P4O10. Now you can also calculate the oxidation state of phosphorus here. So in the first one, the oxidation state of phosphorus is +3. In the second one, it is +4. Third one, it is +5. Correct? Now let's check for arsenic what type of oxides it is forming. So it forms As2O3. It also forms Sb2O3. Sorry, I am talking of antimony also together. Sb2O3 and Bi2O3. Okay, all the elements I have written here. For the rest also, trioxide it is forming. Okay, so let's check the oxidation state for these elements. Arsenic in As2O3, it will be +3. Sb2O3 also +3. Bi2O3 also +3. Check for the next elements. Arsenic can also form pentoxide As2O5, and Sb can also form, that is Sb2O5. These both will have the oxidation state of +5. Both will have oxidation state of +5. Correct? So these are the oxides formed by the other elements of the group. Okay, so let's move to the next one. So down the group, the oxide nature. What will be the oxide nature? As we move down the group, the last element of the group is bismuth. Bismuth, it is a metal. Correct. And metal oxides are always basic in nature. Metal oxides, they are always basic in nature. So down the group, the oxide's nature will be basic. So down the group, the basicity of oxides increases because the last element is a metal, and metal forms oxides which are basic in nature. Now what you have to remember here is, like oxides of higher oxidation state, oxides of the elements, and if the element is having higher oxidation state, then it will be acidic in nature. It will be acidic in nature, more acidic in nature. I can mention that it will be more acidic in nature. Correct? So the oxides, as I told you in the previous screen also, it was there. You find the oxidation state. If it is higher, that will be more acidic. High, more. Correct? Let's check now. So the oxide of nitrogen and phosphorus. Let's check the nature first. The oxides of nitrogen and phosphorus. Now these both are non-metals, nitrogen and phosphorus, they are non-metals, right? So non-metals, their oxides will be acidic in nature. They form oxides which are acidic in nature. Next, check for arsenic. Correct? Arsenic, it will be slight weakly acidic in nature. Weakly acidic in nature. Check for antimony. Sb, antimony, it is a semi-metal, metalloid. So their oxides will be amphoteric in nature. And the last one already I have written here, bismuth, it will be basic in nature. Correct? Let's check now different oxides of nitrogen. Make a note of this. Oxides in which the element is having higher oxidation state will be more acidic. Correct. Let's check this. So the oxides of nitrogen I will write here. Few oxides I am writing. So N2O5, only few oxides I will write. Then we will take the example of N2O4. Then I will take the example that is NO. 3 examples of oxides I have taken. So N2O5, N2O4 and NO. Dinitrogen pentoxide, dinitrogen tetroxide and nitrogen monoxide. Correct. Now my question is, which is more acidic among these oxides of nitrogen? So I told you, higher the oxidation state, more will be the acidic nature, right? So check over here, what is the oxidation state of nitrogen in each of them? So in N2O5 it is +5. Correct? I'll just show how to calculate it. So 2 nitrogen and N we don't know, so I'll write it as N plus 5 oxygen valency minus 2. It is a neutral compound, no charge is there, so I'll write it as 0. Find the value of N here. So that will be +5, correct? Simple calculation. N2O4, that will be +4. Same way you try to calculate this. And NO +1. Now among these, which is more acidic in nature? So as I told you, more the oxidation state, more will be the acidic nature. So out of this 3, the oxidation state of nitrogen in N2O5 is the highest. Therefore N2O5 is the strong acid. It will be the strong acid. Hope it is clear to you, right? So the other oxides also I will just write it. The other oxides formed are NO2, then N2O3, NO2 nitrogen dioxide, dinitrogen trioxide, then dinitrogen monoxide, correct? Then we have N2O dinitrogen monoxide, yes I have written that, nitrogen oxide, that also I have written, N2O3, correct? So these are the oxides of nitrogen. So nitrogen is forming many oxides. Why? Because of the p-pi overlapping. Correct? In nitrogen p orbital is there, oxygen also p orbital. So both are of the same energy levels, correct? And 2p 2p both. So they will overlap with each other and they can form different oxides. So let's check the next one. With the bismuth, one reaction we are having. Okay, with the bismuth, one equation we will write. The oxide of bismuth, that is Bi2O3. The oxide of bismuth, it reacts with an acid. I am balancing the equation and writing, correct, and it forms bismuth nitrate, bismuth nitrate and H2O. Correct, bismuth nitrate and water is formed. Correct, this is also one of the equations where bismuth oxide reacts with HNO3. Okay. Now this acidic nature, as I told you, of the oxides, it not only depends on whether the element is a metal or non-metal. It also depends on electronegativity. The oxides acidic nature or basic nature, it also depends on electronegativity. Correct. Now as we move down the group, we are moving from nitrogen to bismuth. Nitrogen is a non-metal, bismuth is a metal. So metals, they are electropositive. So as we move down the group, electronegativity decreases. If electronegativity decreases, the acidic nature of oxides, also decreases. Correct? Correct to know, because acidic nature of oxides will decrease. Bismuth is a metal, it will form a basic oxide. So the acidity or basic nature of the oxide depends on whether the element is a metal or a non-metal. It also depends on the electronegativity. So here we complete with the reactivity towards oxygen.